I'd like to talk about some more definitions for vectors. First of all, for vector v in the particular given form and vector w in the given form, the dot product v dot w is defined as the product of the two horizontal components plus the product of the two vertical components. Be careful, dot product does not mean you're multiplying as we would in algebra. In other words, you don't FOIL the two vectors. So do be careful about that. Okay, there's a theorem that says if u and v are non-zero vectors, the angle theta, for theta between 0 and pi, including either 0 or pi, the angle between u and v can be found by the equation cosine of theta equals the dot product of u and v divided by the product of the magnitude of u and v. Okay, two other definitions. Two vectors are parallel if and only if the angle between the vectors is either 0 or pi. Another definition, two vectors are orthogonal or perpendicular if and only if the angle between the vectors is pi over 2. The angle between the vectors is going to be pi over 2 if the dot product is 0. Okay, so let's look at an example. If the vector v equals square root of 3I minus 3j and the vector w equals I minus j, find number 1, the dot product, number 2, the angle between v and w, and then number 3, if v and w are parallel, orthogonal, or neither one. Okay, so let's first of all work on the dot product. Okay, so v dot w. Okay, on here what we want to do is we want to take the horizontal components from both of these vectors and we want to multiply them. The horizontal components, you'll see over here there's understood ones with these. The horizontal components are the square root of 3 and the 1. So we'll take the product of those two things first, and then we'll add the vertical components. We see that this is negative 3 and negative 1. And so the dot product is the square root of 3 plus 3. Okay? Now, the way we use the dot product, in the definition of the angle between v and w, you see the use of the dot product. Okay? On here, let's say we want to find theta, meaning the angle between v and w. Well, we know that to do this, we have the formula that says if we have the dot product in the numerator, and then we take the product of the magnitudes in the bottom, then we know we have an equation that involves theta. Well, we already have the dot product, so that's taken care of. Let's go and let's find the two magnitudes. So we need the magnitude of v. That's the square root of the horizontal component squared. Horizontal component for v was the square root of 3. That needs to be squared, plus the vertical component, that was negative 3 squared. Okay, square root of 3 squared is just 3. Negative 3 squared is 9. And so this would end up being square root of 12, which simplifies down to 2 square roots of 3. All right, let's find the magnitude of w. The magnitude of w was its horizontal component squared. Its horizontal component was 1, plus the vertical component was negative 1, and you're squaring that. This would end up being 1 plus 1, so this is square root of 2. So now that we know the two magnitudes of v and w, we can use our formula. So going back to our formula, we have the cosine of theta equals the dot product of v and w. From above, we found out that that was square root of 3 plus 3. And then in the denominator, the product of the two magnitudes. One of them was 2 square roots of 3, and then the other one was square root of 2. Okay. You don't really need to simplify this because what you're wanting to do is you're wanting to solve for the angle. And so to solve for the angle, we'll have theta equals the inverse cosine of the formula that you have written down up above. Okay, the only reason you might want to simplify the formula just a little bit so that it's easier to type in your calculator. on the top of this guy, you'll have to open up a parenthesis on your calculator saying that this is the denominator. In the numerator, we also have to open up a set of parentheses, but in the numerator we could say that this is 2 square roots of 6. Okay, so do be careful when you do this to use parentheses in the appropriate places. Typing this in our calculator will actually end up with 15 degrees. Okay, so that's the angle between these two vectors. Okay, and then the last question, it wanted to know if V and W were parallel, perpendicular, or neither one. Okay, well, the angle was not 0 and it was not pi, and it was also not pi over 2. And so that being the case, I would say that this is neither. Okay, this concludes this example of dot product.